Okay, so let's ls into the genome directory again. So we have 4 files here. So what we are going to do is to create a bash script, and then in that bash script we will indicate all the necessary commands that we will use. So that's what we are going to do next. So let's do this. Let's create the scripts, and of course you should also make sure you know the directory that has all the necessary files or input files. Of course, we have this one here. So we will create a script. So I'll say nano run busco.sh. You can use any text editor, that is fine, but I prefer to use this one. So I'll have it open. So I'll indicate my shebang line, and then I'll come to this side. So what I'll do first is to create a directory called BUSCO summaries. Let me just add this, create a directory to store the summaries. This is what I have done here. And then I'll now also define the lineage. So I'll say lineage equals this. Let me add this. So after that, I'll now use a loop to iterate over each of the files and then run BUSCO on them. So I have 4 files here. So this is where loops come in handy. So if you have 4 files or more than 4, then it's important to use loops. Then you can write a generic command that factors the names here. So I have 4 files and I know their names, by the way. So I will say for sample in, and then I'll indicate the names. Okay, I have the names here. So I have this, I'll just put all of them here. So this is one of them. Let's add just the names. I'll just copy them because these are few. But if you have, let's say, 20, 30, 50, or hundreds of files, there are better approaches to do that. And if you have such a situation, you can always reach out to me. So for these ones, I'm just doing a copy and paste just to get them. So I have them. And you should also notice that I did not specify the .fasta. I'll indicate that later on, but for now, I just want the names. So that's where it's important to also have a good naming convention when you are doing bioinformatics analysis. When you have lots of samples or lots of data sets, then having a good naming convention allows you to easily automate the analysis process or analysis pipeline. Okay, so I have them here. So for sampling this. So I have 4 files. Then I'll say do. So the do should be lower caps. Then I'll just say busco -m, and I'll say genome, that is the mode. And I'll say -i, that'll be genomes/, now do this $sample. So $sample here is this one. So because we have 4 files, each of them is this one. So we are iterating. So at a particular point in time, the sample refer to this. At some point in time to refer to this. So that is what this dollar is. So the $sample here indicates the actual name or the actual value. So in this case, our sample names here. And then I'll say .fasta. So we have the genome directory, and then we also have the sample, and then we also have the extension .fasta. So that is what I have indicated here. And then I'll say -o, and I'll say $sample underscore BUSCO, and I'll say -l, then I'll indicate the lineage. That will be $lineage. I define that here. What else do we have to add? That is it. Now, what we need to do next is to copy. If you take a look at the instructions here, after generating the BUSCO outputs, we need to copy some files. So we have this one here, short summary, blah, 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 blah. Now, let's take a look at this. I think I have mine opened. So when we are here, we need to copy this one, this file here. This is what we are going to copy. And that is the next command we will indicate. So that one will be here. So I'll say cp $sample underscore BUSCO slash, and I'll say short underscore summary. And then I'll say .star. Let me bring a quote here. It's quotes $lineage. $sample, and then I'll say star.txt, and then I'll say BUSCO underscore summaries, because I am copying it. I'm copying the summary file from the output. So that is how we will do it. And then that will be done. So this is how we will run BUSCO to evaluate all the assemblies that we have. And then we also make a copy of the summary into another directory. So let's execute this command. Or let me just say, let's execute the script, because now it's a script now. Okay, so we are done. And then let's do an ls, and we are going to find this file here, which is the bash script. So we can say chmod +x run busco.sh to add execution rights. Now with this sample, we already generated a BUSCO output, which is here. And so if you run BUSCO indicating the same directory as the output, then you'll have an error. So what you can do is to put this output somewhere or remove it completely. I am going to remove it completely. So I'll just say rm-fr, then I'll call it. Now you should be careful when using the rm command. I repeat, you should be very, very careful, because once you execute it, you cannot recover your files again. So you should be very, very careful. Okay, so what I want you to do is to make sure that you review whatever you are going to delete before you run this command. So I am going to remove this directory first, and then I am going to run BUSCO again. By this time, I have it in this script, so that's what I'm going to use. I'll just review the command again to make sure everything is okay. And now I'm going to run it. So I'll say with the run, you can say // and then you specify the script. This will work. You can also use bash, then say run _ busco.sh. I will use this approach, by the way. So let's execute the script to get the output for all the samples. Perfect. So now BUSCO has started this way. So let's wait for BUSCO to complete and then we can proceed. Okay, BUSCO has completed the evaluation for the genome assemblies. So let's take a look at the outputs. So let's do an ls and we are going to find some directories. So we will have this directory, BUSCO _ summaries. So this directory has the summaries for the 4 samples. So the 4 samples, these are their respective outputs. We have this, we have this, we have this, and we have this. So these 4 directories are the output for the 4 genome assemblies.